up, Song Squads? Welcome back. We are going to do factoring polynomials. So there's lots of methods. If you watch my other videos with quadratics, that's specifically for quadratics. But what happens if it's a higher exponent? So there's a few. There's sum and difference of cubes. There's difference of squares. There's just your basic trinomial. There's factor by grouping. And then the last one is a quadratic form. So my goal is to hit all these up today. So sum and difference of cubes happens if it's a binomial with your leading coefficient as the power of 3, highest exponent, and then a constant value. So there's no values in between. So if you could write it as a cubed plus b cubed, or a cubed minus b cubed, it's very similar to difference of two squares. We get two formulas. We get a plus b, a squared minus ab plus b squared. And then if it's the other way, you get a minus b, and you have a squared plus ab plus b squared. So you do need to memorize the formulas. You know, it's same, opposite, always positive. That's how I teach my kids. So if it's negative, then same, negative, opposite, and always positive. All right. Difference of squares. If it's a squared minus b squared, if you can write it in that form, then we can state it's a plus b, a minus b. But still has to be binomial. It has to be a perfect square. Factor by grouping happens normally if it's 4 terms. Not always, but if it has to be 4 terms. Usually with a cube, and then just kind of going down in descending order. So you have like an x cubed, x squared, x, and then a constant value. So then you can use grouping, and I'll explain that. And in quadratic form, this takes part of quadratic, pretty much the form. So for example, if I give you a problem like this, right? And if I just switch this exponent and I start doubling it, we can still treat it as if it's just quadratic, or even if I triple it, right? So all these methods, it has to be 6 there, and then if I keep doubling these guys, we have 4 here and 8 there. You can see that I'm jumping by 4 or jumping by 3, but still a trinomial, then we can use quadratic form. So then the question becomes, well, how do you do a problem like that? So well, if you factor this using guess and check, you get what? Minus 1, right? But if I change it to squared into the 4th power, you get squared and squared. If I change it to 3 and 6, then you get 3 and 3. But then the math itself is the same. Nothing changed on that part. All right, so that's an example of quadratic form. Sum and difference of cubes. Let's say I give you a problem like this. X cubed plus 8. Well, we can rewrite it like this. 8 is a perfect cube, 1 is a perfect cube. So then we can write it like this, and then this becomes A and that becomes B. So then all we have to do is know this formula, substitute it in. So you have x plus 2, and you have x squared minus AB, so 2x, plus 4, which is B squared, and you have that. We do need to test to see if we can factor more here because it is quadratic, and see if we can go further. Same difference if I change this to a minus 8, then you can just make everything opposite, always positive. Another quadratic form, if I combine it with difference of two squares, I can think of it as like x to the 4th minus 16. Right? I could think of this as difference of two squares, still a quadratic form, because I could think of it as x squared squared minus 4 squared. Instead of if it was x, it would be x squared minus 4 squared. So then how do you factor this? Well, it's x squared minus 4 and x squared plus 4. And then we have to go one more step and see, can I factor more? Then here I can't, because that is difference of two squares. So it's a plus b, a minus b. And get that. All right, so then you have to test. We can't go further here because it's linear. We can't go further here, it's linear here. We can't go further because it's a plus. We don't have sum of squares. We only have difference of squares. So we can't go further there. Alright, so that concludes our lesson with factoring polynomials. We're going to do 3 problems. Try your best. Let's get ready for those problems. Good job. Alright, our basic problem, let's take a look. If I give you a problem like this, 3x cubed plus 3. Remember, your first step always with quadratics, when we learned that lesson in my other videos, was to take out GCF first. So take out GCF and then see if it fits one of these guys here. I left the formulas up for you guys. Try your best. I need about a minute for this. Don't give up. Go. Alright, welcome back. Let's take a look. So what's my GCF? What do they both have in common? They have a 3 in common, so I'm going to take out the 3. If I pull out the 3, then you're going to divide everything by 3, so you have x cubed plus 1. And now the question is, x cubed plus 1 doesn't look like any of these guys. It actually looks like that yet. Reason why is because we can say 1. 1 is that weird number that it can be a perfect square and a perfect cube and a perfect anything. So I can think of this as x cubed plus 1 cubed. Now we use this formula where a is x and b is 1. So when you do this problem, you have x plus 1, same. A squared, opposite, AB, so 1x plus 1 squared, b squared, which is just simply just 1. All right, and we can't go any further here, so that is my answer here. All right, so check your answers, make sure you guys did this correctly, and then kind of go from there. All right, great job. All right, next problem. Let's say we have x to the 4th minus 2x squared plus 1. It's a trinomial. It's jumping up by 2's. That's your hint. You're going to have to use quadratic form. Try it. Don't give up. Go. All right, I want you to think of this problem as this. If you got stuck, think of it this problem and see if you can factor this guy. If you can factor this, we're good to go. This is actually one of our examples almost. So what is that? X minus 1, x minus 1. That's if it was 1 and squared. If it's 2 and 4, then what do we just have to change? We just have to change that guy there. All right. But the question is, are we done? So most of you guys might have gone here and stopped, but you have to ask yourself, can we go further? We can, because these two guys are actually a difference of 2 squares. So you have x plus 1, x minus 1, and then on the other side, same thing, we have x plus 1, x minus 1. Can't go any further because each one is linear, which means that the highest exponent for each factor is 1, so you can't go any further. So check your answers. It is tough. Most of you guys might have gone here. We do need to go one step further. All right, last one, our advanced problem. If I give you 2x cubed minus 6x squared plus 2x minus 6. It's 4 terms. Maybe take out GCF first and then group them. So when you group them, you're going to group them separately. So I'll kind of start you guys out. I'm going to help you take out the GCF first. That's my GCF. Don't worry about the 2 until the end. And now what I want you to do is kind of group these guys. And then see if, take out GCF here, take out GCF there if there is any, and then see if you take out another GCF. So try your best, 30 seconds to a minute, go. All right, let's take a look. So what I want you to do is take out GCF. What's my GCF here? That's where we're grouping my GCFs together. So I can take out an x squared, and what's left over, you have x minus 3. Here, can I take out GCF? No, but there is a 1 on the outside. You have x minus 3. So we took out GCF for both separately. Now we're going to look at each term together. What do they both have in common? Good. They have x minus 3 in common, so I'm going to pull that out. What's left over? If I take my GCF out, these guys are what's left over. So you have x squared plus 1. And then you have to ask yourself, can I go further? Well, here it's linear, so you can't. 2, you can't here. It's almost, because if it was a minus, then we could use difference of 2 squares. Because it's plus, we cannot. So this is my final answer. All right, so grouping is not easy, but try your best. So that concludes our lesson with factoring polynomials. Hopefully this video has helped you. Please subscribe to my channel. Please turn on notifications. Let's get ready for some math videos. Good job.